Okay, AP Physics, UT Quest problem in uniform circular motion. This is the tire performance problem. And you're given this particular problem, and normally you just go about your business, go, I know how to do this. I need to have a force of friction pointed towards the center of the circle, and then I can easily calculate anything I need, knowing that the force of friction is my agent for uniform circular motion. The deal in this problem is we are given this thing. And dv dt, that's just a fancy calculus term meaning acceleration, meaning the rate change of velocity. So what we do here in this problem, we have two accelerations. So we have to account for the forces for both accelerations. So let's take a free body diagram and let's see what I'm talking about here. Okay, now this is the problem that we've done over and over again. All right, I've got some horizontal circle thing and a car or a person or whatever traveling around a circular track. And I know that that acceleration towards the center is due to friction. So that agent there, we'll just call that force of friction centripetal. And we know that that is mu of S, force normal, and force normal in this case is going to be equal to the weight. Now, the wrinkle in this problem is this guy right here. Not only do we have an acceleration towards the center, we also have an acceleration forward. And that acceleration forward is also going to be due to the force of friction. So we need to add these two forces together. Okay, so let's dig into this a little bit deeper and see what we need to do. All right, we need a total force of friction. That's a force of friction centripetal pointed towards the center. And we also have this force of friction that propels the car forward, because the car is accelerating forward as well as accelerating centripetal. Now, we have two forces that are perpendicular to each other. How do we solve that? Well, we solve that by adding these two together. We must add them together by Pythagorean, because the force total of these two is going to be the hypotenuse. Okay, so let's substitute in some terms for force of friction centripetal and force of friction forward, which I'm calling force of friction tangential. Okay, this guy over here, we've done this problem many times before. That's going to be mass times acceleration centripetal. I'll substitute that in. Now, what about this guy over here? The tangential, it's linear, it's straightforward. So that is just mass times my given acceleration. Now I'm going to substitute these in, and at first it might look kind of messy. So when I put these terms in, remember this ace of C here, I have everything I need to calculate that. I know the tangential velocity, I know the radius, so that's just going to be a coefficient squared plus the mass, or excuse me, times the mass squared. Same thing with the given acceleration in the mass, that coefficient squared plus the mass squared. I can combine those two terms and then take the square root to get force friction. Now, once I have force friction, then I can take force friction and divide it by force normal. In this case, force normal is just equivalent to the weight. And then I can then that calculates mu static, and that answers this problem.